All right. Hello and good morning. Sorry, I started the wrong session. Anyways, yes, so we made some changes to the State Machine API yesterday. So we're going to try to refactor the app now. I've already updated it with the latest version. I hope this is the last iteration. It's been like, this is a really good way to do API design. Like actually building something that's going to use it and then see how it fits. Like how does it actually solve real world problems? But yeah, so what did we change? We changed. Yes, we changed. Yeah. Okay, so we have these machines, and then we decided that we wanted to export a function that's kind of like a factory, where we can control what should we decide from the inside when we create a state machine. So for example, the initial state, any state related to that initial state, and then the base state, as we can see here. So I don't want to like manipulate anything from the outside. I want these machines to just start out like hard coded. But having parameters here gives me the possibility to change up whatever I want, really. But yeah, so that seems like a powerful thing. Create app. Oh, let's see. We made some changes to the typing, didn't we? So we're calling it like app machine. Yeah. Let's see. Let's change this. Yeah, so this also solved some stuff that we have explicit typing of the machines, which is really nice. So we actually type it as a machine, and then we can use that type when we build up the nested machines, like you see here. So that's super nice. So it's coming together. Like state machines is a more complex way of defining state. That's for sure. But that's typically the way it is when you deal with dealing with things, like dealing with more complexity. So like plain state is just a value. There's no control of that value. You can change it whenever you want inside an action. But now we have like transition states, and we have logic that clears out the existing state, and so on and so on. So the API is doomed to be a little bit more complex. But hopefully we come to a place where it makes sense. So you create a machine and its transitions, and then whenever you want to create one of those machines, you point to it and you say create. Give it the initial state, whatever a related state is necessary for that transition state, and then the base state like this. Okay, cool. What were we going to do? Yes, we made some changes, and I guess we didn't make any changes here. I'm just checking if everything looks okay. Yeah, where the changes are is in the actions. So now we have this authenticated thing. Okay. And then we have, let's see, transition. Maybe we should just look at the errors. So what we changed is that we don't use this matches API anymore. We rather check if we have authenticated state. And then let's see, and do this right way. So if we are authenticated, we can say state authenticated app, and then we transition. So when we try to open add backlog item, the page, we check if we're authenticated, and if we're authenticated, we point to the app and we transition into that page. Now the point is, just to iterate what we did last time, if I were to remove this, TypeScript should have started yelling at me. Oh, did we install the latest version? This is supposed to be, oh god damn it. This is supposed to be or null. Let's see. Let me just double check if I actually installed the latest version. That's weird. That's weird. I was pretty sure I did an update. What is the latest version? 26. That's weird. Oh no, not again. Oh, god damn it. I'm like, this is what happens. Like this is generally with developing applications, you have these issues, and then so in this case, it's the type fetcher of Codesandbox, and it has some issues. It fills up for some reason, and we can't figure out why it fills up. But we can do this one little thing that takes like 2 seconds, and then everything's okay. And we really try to figure out what's wrong there. But because we have this quick fix, it's not like we're forced to fixing it. And yeah, I can relate to that in several episodes, working on other projects as well. You tend to just do that quick thing because there's so many things that needs to be done. And then as long as you can spend like a couple of seconds every time this happens, you kind of, okay, let's just do that so that we can work on this other important stuff. But as you can see, it completely blocks working on this app now once more, which is super annoying. So maybe I can rather show you. So I'm going to, this is like, now I'm really fed up. This is like the 3rd or 4th time I'm blocked on the stream because of this bug. So this is the last straw. I'm going to yell at stand-up today and say that I go on strike if we don't focus on this now, because this is getting just embarrassing, really. Okay, but I want to show you something else I've been working on, which is related to this visual tooling. So I'm not going to talk about the visual tooling. I'm rather going to talk about the underlying thing that allows this visual tooling, like actually building something visually. Okay, so we'll just keep that saved. Let's go to, what did I call it? Injectable store. Yes, let's see. I'm just going to remove everything here. Blah. Okay. So, how should I introduce this? So I was just playing around with this idea. There is this concept that is not very well known in the ecosystem of web applications, and it's called inversion of control, or IOC containers is like the implementation. IOC is like the concept, and then IOC containers, inversion of control containers, is the implementation. And there are libraries that does this in JavaScript, but they're not like a typical go-to thing. And the reason, I guess, is just the history of JavaScript and the web. We haven't really had the need for it, but it has some interesting benefits. So, for example, in Overmind, you really want to. So one of the core implicit features of Overmind is that it doesn't matter what action you're running, the action always has access to all the state of the application and all the effects of the application, and all the other actions of the application, which is really important in my experience, because when you start isolating state and logic and effects, you always get into this situation where, oh shit, I implemented this new thing, and it actually needs some state from this other thing, and then you have to refactor your whole application to make that possible. And this is why I have this itch with components, is that it happens all the time with components, because by its very definition, you have a component, you isolate state and logic, and then you have to keep moving it around and then pass it as props down. So this is really powerful, and like Redux has the same. Like you have these action things which has access to any other dispatch and state, and it doesn't matter. It's a state tree. Now the interesting thing is that Mobex introduced classes. So you would rather write a class which has state and related logic. And this is a really nice way to conceptualize something. So in Redux, for example, the reducers and the things are often defined very at different places. So it's hard to reason about what's a concept. A concept is rarely just state. You also have some logic related to that state. And that's hard to reason about in a Redux application, depending on how you structure it, because they are linked in some way, but they're not defined together. But with a class instance, so in Overmind, for example, they're also defined separately in different files, but at least they're defined within the same folder, like the same namespace. And you could do the same in Redux if you structured it that way. But in Mobex, using classes, you always define the logic with the state, which is arguably a really good thing, because whenever you look at a concept in your application, you see the state and the accompanying logic for that state. Which makes it way easier to explore it, and so on and so on. The problem, though, with Mobex classes is that they work just like components. So if you want to access state and actions from other stores or classes, you have to do some serious props passing. Or what should I call it? Arguments passing. Like you have to have one main store which instantiates other stores, and then you pass those down to the other stores who needs it, and then you have a circular thing, and it's a little bit tricky. And I wonder what like Michel, the author of Mobex, I see that he actually has a comment on this project called Inversify, and maybe I've completely lost this. Here you have him, Michel, author of Mobex. Dependency injection like Inversify works nicely. That's like awesome comment. Anyways, yeah, I might have completely missed this, but it doesn't seem like he has introduced IOC containers for like related to Mobex. Maybe he does in some like advanced classes or something, but maybe it's just because it doesn't want to take away the core of Mobex. But the point is, when you introduce this IOC concept, you suddenly start to get some new benefits. So what I did is that I just wanted to explore this, and then it turned out that doing this actually sets the groundwork for doing a visual tool on top. Again, I'm not going to talk about the visual tool, but I want to show you what I did here. So if you think about Overmind, its structure is a state tree. So everything's defined in these trees. All the actions, all the effects, all the state are defined in these trees. So that's one way to deal with it. But the typing there is freaking hell. Like it took it took the most time was working with the typing of Overmind. It's crazy complex. But yeah, so anyways, so let's see how this actually works. So what you would do is, first of all, you would define like an interface for something. So let's call it app. IApp. Now the reason you use an interface first is because when we start to make dependencies between our different stores or classes, or like it's not, let's call it classes because it's not necessarily just a store. It can be like an effect, for example. We can explore that. Is because you want to have the typing, but you don't want to point directly to a class in any way. You just want to deal with the typing. So that is why you create an interface. And this interface, like it might have like a title, for example. And then we create the actual application class, which implements our IApp. So this is like the contract with the other classes. This is what you want the other classes to be able to do. It being accessing some state or running some piece of logic, for example. So what we want to do here is we want to say like title equals my awesome app. Okay, now the question is like, what do you do from here? Like typically you would say app equals new app, but this is not what you do in the IOC container concept. What we will rather do is we will export our app, and we are going to create an app, and we are just going to attach our app. Maybe we can just do this. We're just going to attach our app in this dictionary, and every single class is going to be part of this dictionary, it being some kind of effect, or it represents a store, or it represents anything else. These are like the entities, the structure of the application, but it's not a tree. It's just a bunch of individual nodes that you can bring together in any way you want. So the question is like, how do you instantiate this thing? So let's do that. Oh yeah, I already did some stuff here. So we have our app here. Let's just call it instance. And it's already typed here. So now I can say app get app. Maybe app is a bad name. It's actually, let's call it container. It's like, that's what it is. It's the app container. And then we have our app here. And then we can log out app.title. So you see like everything's typed and ready for you here. Let's bring up the console. And now we have my awesome app. Now the thing is, what if I wanted to do some, I don't know, some HTTP stuff? Well, let me explain first what happens. So here we just register a class. When I call this get app, it will create an instance for me, right? That's basically what it does. It creates the instance of the app. So what I can do now, I can building some other piece of the application. So for example, I want something like iAdmin. Let's just do that. And then class admin implements iAdmin. And maybe this has a, I don't know. I'm just going to use like a foo thing. And foo equals bar. Okay. And now let's register this admin here. Now, if I want to be able to, let's create an action here, which log console.log this.title. So let's do that instead, and we'll just call log here. Cool. So what I want to do, I want to bring in this admin. So this is some other namespace. I want to bring this into my app because I want to access this foo thing. So what I can do here, I can use this decorator, and I can point to admin, which is the class I want to use. And then I have to give it a name. So I'll just give it the name of admin. And then I need to give it the type. So iAdmin. So this is kind of weird that we're defining it in the same file, but you can imagine the admin and the app being in different files. And the reason I did the exclamation mark here is because TypeScript would yell at me because I wouldn't like instantiate it in a constructor. And then I use the interface because we don't want any circular reference to the classes themselves. Like types can be circular, that doesn't matter. So anyways, I'm injecting an admin in here. So if I do this.admin, and now you see this is typed, and I do foo, and now I get bar because it will automatically create an instance of admin for me. right? So I don't think about this. I just define these classes completely in isolation, and then they can inject each other, and they can cross-inject. So I could also inject app into admin if I wanted to do that, and it would just work the same way. So that's really cool. So you get like cross stuff. Okay, so that's one part of this. And then you can imagine you want to like make things observable from the outside. So this library, like the foundation of this thing I'm working on, it just exposes MobX really. And the reason it does that is because MobX is built for classes, and you deal with state values individually. Unlike, for example, Overmind and Redux and Cerebral, where it kind of, you think of it as a state tree. What you would do here, you would say like observable. Maybe we can do it like this. I don't know what looks best. Observable title. Yeah, anyways. So now we have actually an observable title, which means that if we were to change this title, anything observing it would actually change. And this is basically how MobX works with React and everything. But you explicitly say what is observable state and what is not observable state. And then you have things like computed, which you also kind of just use. So you have like computed, get upper title, for example, and then you would return this dot title like this. And if and even here you could like point to admin foo, and if this was an observable, this computed will actually run whenever the admin foo changes. So you really have this cross dependency thing. It doesn't really matter how. So you structure it based on your mental understanding of the domain you're working in, instead of adhering to the limitations of like circular dependencies in code. And you could argue that circular dependencies in itself is like a bad way to model a domain, but I don't think so. I think the stuff we work on is so complex, often so complex in nature, that it makes more sense to have these circular things than not having them. But that we could argue that to death. But yeah, that's at least the reasoning behind it. So what if I wanted to create multiple instances of something? Are we on time? Yeah. So what if we had like something called like a to-do, which had like a title, and completed would be like a boolean. So I would still just create a class called to-do, and it would implement I-to-do. And then like the title, and then I could use observable here and say title equals this, and observable completed equals false, for example. So I have my to-do here, and now I don't want to create one instance of a to-do. I want multiple to-dos. So what I do first is that I create an interface called I-to-do factory. This is pretty straightforward stuff, where the args are constructor parameters of type of to-do, and then it returns an I-to-do. The reason it yells here is because to-do was used before it was defined. This is silly because it's typing, so ESLint isn't able to see the difference here. But anyways, so this basically just describes the arguments you pass into it when you instantiate it. So currently there aren't any arguments, but let's say I wanted to be able to, so this is typical for factories. You want to override the title. So title would be string, and then this title would be title, something like that. Now this type here understands these parameters, which means that in admin, maybe I wanted to have a list of to-dos. And this would be like I_to_do equals something like this. Oh, I guess that's it. An inter. Oh, sorry. This is not inter. Sorry about that. So we wanted to have to-dos, I_to_do. So that's like an empty array. And we want to be able to create to-dos. So to do that, we would, instead of using, oh, sorry, we need to add to-do to our list here first. So instead of using inject, we're going to say inject factory, and we're going to inject a to-do. And then we are going to say, for example, create to-do. And then I_to_do factory. That's the type of it. Oh, sorry, I have to do this thing. Okay, so now we have this factory, which means that if I were to add something like add to-do here, and maybe this would actually take a title string, I could say to-do equals this create to-do. Now this is actually typed. Because I added a string here on the to-do, this is already typed for me. So I pass in this thing, and then I'll say this to-dos push to-do. And maybe I'll make that an observable as well, so that any piece of UI will be able to react to any changes to it. Okay. So maybe we can try to actually add a to-do here. Let's see what happens. So let's app admin. No, sorry. Yeah, admin. Yeah, sorry. I haven't exposed. Add to do is title string, and it doesn't return anything. So admin add to do whoop-de-do. And then let's just console log app admin to do's. See if that works. Oh, I thought that would work. I'm still working on this, but in theory that will work. I wonder what happened there. Object is not a constructor. Ooh. New proxy. Yeah, I'm not sure what happened there. I did something wrong. Anyways, the point is that that will work. Create to do. Sorry, now I got stuck in why this doesn't work. Anyways, let's just conclude, and then I'll try to figure out what happened there. So the point is that you choose if you want, how you want to integrate the other classes into a class. So either you just use a single instance, which is basically your core namespaces. But then you can have classes that represents like entities like a to-do, for example. And those can be a factory. And it doesn't matter, like all these classes can be used as factories if you want to do that. And then you might have like some effect. So for example, maybe you have an HTTP class, which represents how you do request, or like an API class or something. And that API class can be injected into anything. So we could inject, I need access to the API here. And you just do that. So every instance of a to-do actually has access to the API. So you don't have to, like, I wouldn't say artificially separate things. Like separation is also a good thing. But in terms of dealing with like global state management, I find this really, really fascinating. Yes, I do. Anyways, so, okay, so I can give one hint about the visual tool. So the visual tooling in terms of global state management is a question of what do you want to visualize. Like currently we do visualize the whole structure of the state and whenever values update. But in terms of building something using a UI, it doesn't really make sense to build the state tree using a UI. You can just write code because you basically do the same thing. Like it would just be like, I guess there's some value in the accessibility of having like a visual representation and maybe having some like inputs instead of like a code editor. But at the end of the day, you are basically just writing code because it's just like a JSON structure. So where this becomes very interesting is how you connect everything. So you can imagine, okay, I'm going to talk about it. So you can imagine that each of these classes represents a node in the visual tool. So if you wanted to create a new class, you would just drag, okay, I want to create a class. You drag it onto the canvas and you give it a name. And then boop, a new file pops up with that name. With the typing and everything ready to roll. And then when you actually set up the state and what's observable and all this stuff, you write normal code. But then if you want to attach some other class to it in the visual editor, you can just drag a line between, for example, what we did here. You can just drag a line between admin and app, and then you can position these nodes visually in your editor so that it fits with your mental image of how your application is connected. And you do that, and then this visual editor will automatically create this injection thing for you. But if you were to write it manually, it would also create this line between these two nodes visually. And where things gets really interesting is that we define these observables and the computed actions and stuff right there on the class, which means that this can be automatically populated in the node as well, showing you what is happening to this class. So you kind of get the only thing you visually build is the relationship between everything in your app. You're basically creating the mental image of your app visually. But what happens inside each of these nodes, each of these classes, is something you still write in code, because I don't see any good way to do that visually, at least not yet, where the visual building is like more powerful than writing the code itself. Because you get into, what about all this typing? Like, how would you deal with that in a visual tool? It's just horrible. Anyways, I want to see what the hell happened here. Maybe I don't have the latest version of this. Console.log. What am I trying to inject there? ID rx. Oops. ID rx. App admin. What the hell is this thing? Object is not a constructor. Oh, is it because it's already... Oh, I think I know why. Oh, yeah, I know why. I know why. This is... It's only if the constructor is like a function. We want to do this. Let's see. I used to have this check, but I removed it. Yeah, type of... I guess type of instance. Yes, if type of instance is function, then we want to create a new proxy, and then we want to set it, I think. Yeah, there we go. So here we have our to-do. Yeah, with our title and everything. Anyways, so that's something I've been working on the side. I guess you could use the import type syntax to avoid having to... Yeah, maybe you could do that. That's a good point. Etienne, because I based this implementation on existing concepts and documentation, and stuff has happened. Because that would be really, really nice. Let's try that. Let's just see if it works. I guess we still need this one though. But I guess we could... or maybe, yeah, let's forget about this one for now. Let's just remove all of this. Simplify it a little bit. Because that would be really interesting. Though then you would have to be very explicit about using import type. But I guess that would kind of solve itself. So you have... Okay, let's just do this. And then, well, I guess we can't really see it here. Let's just... Oh, anyways, I don't want to go into this now. I have to stop, but yeah, it's a really interesting point, Etienne. We should explore that, because then you have even... It feels cumbersome to every time you want to add something to a class, you have to add it to the interface. You rather want to use the class, and then you use like private and public to let any consumer to know what they should be able to use. But yeah, that's very, very interesting. Okay, I want to try it. Admin TS, and what do we call the other thing? App TS. Oh. Let's remove this one so it doesn't... Okay, we don't need to render anything really. Okay, so we have admin export class observable foo. Why is it yelling about that? Oh, didn't it? Well, that's weird. I have no idea why it didn't pick that up. That's weird. Anyways, index, sorry, app, sorry, test. Then we have our app. So basically what Etienne suggested here is that we do import type admin from admin. I guess this is how you do it. Yeah. Yeah, let's copy the other stuff so it looks... inject computed. Yeah, I have no idea why it doesn't pick up the decorators config here. But anyways, this should work, yes. Oh, not imported anywhere. Yeah, okay. Yeah, because what I was thinking with the factory, you would say like inject factory, and then you would kind of... So we could have like a type. So let's imagine the library exports like this interface of iFactory, and then there's a class inside called new... what's it called? I don't remember. So like t extends object or something, or just like this. And then you say args constructor parameters, something like this. Yeah, I'm a little bit unsure about the typing here, because you have to... This is like new args any. So I do not think so. This T needs to be the new version. yeah, I don't think there's any way in TypeScript to properly type constructor parameters, because it's the class itself defines the ending result of the instantiation, but the constructor parameters is not part of the final, if that makes sense. So typically when you create an interface for a class, you can't add the constructor typing there. You have to have like a separate interface for the constructor typing, because the interface of the class is the result of the instantiation of the class, if that makes sense. But anyways, let's see what happens here. So you kind of do something like yeah, because now it complains, because admin is like the result of the thing. So I can't like pass, I can't like extract the, or maybe I could like, I have no idea how to do this. I think it needs to be like, how would this work? I think you would have to like explicitly do, so you would do like t extends any, and then u extends like something like this. So if you do explicitly do admin and then admin, and I think it works. Does it? Oh, doesn't satisfy. Oh, is it? Oh, sorry. Is it because I just don't have any constructor parameters there? No. Yeah, so this is what I don't understand about the... Oh, you have to do this. Yeah. But doesn't that mean that it actually imports the value and not the type? Or is type of also allowed for like other things? So if I have like interface blah type blip type of blah, I can't do that, can I? Yeah, not being used as a value. That's what confuses me. Like this is supposed to be a type, but here we treat it as a value. I wonder what happens to this import if we do that. Yeah, anyways, but that's like a detail. Like it would be possible to, if you want to use it as a factory, it's still way better to do this. Where is it? It's still way better to do, where is it, admin? Because the point is that I admin factory. Yeah, I guess this would have to be type of admin as well. Oh, and this, oh, I guess admin. No, this doesn't work either. Oh, it was used before it was defined. That's okay. But yeah, I wonder what happens when what actually happens to the, if I import this, what happens to the, when I use type of admin here, what happens if I like export this and then this uses type of admin? Will it still kind of remove that import? Okay, that's just something to test then. And I also wonder, like, can I do, so if, I guess, so type, I can't like do it there. Yeah, it's being used as a value. Yeah, so you kind of, ideally I would want to do this, but I don't see how I could do that. yeah, anyways, that's something to explore. Maybe you can help me with that, Etienne. I want to do this. I want to import type the class, and then I want to say ifactory, give it a class, and it should return a function with the constructor parameters and say that it returns an instance of this thing. Or basically returns this thing. That's what I want. Anyways, thanks for following along. And yeah, I hope this made sense. But yeah, tomorrow let's get back to building our app again, and I'll let you know when I get some more progress on this this stuff. Cool. Bye for now.